Hello friends and welcome to another tutorial on Geeks for Geeks. In this video, we are going to understand the program which helps us in calculating size of a tree iteratively. First, let us take an example. Size of a tree is the number of elements present in the tree. Size of the below tree is 5. Now, let us have a look at the algorithm. Let us also have a sample tree to test our algorithm. As root is not null, we create a queue and enqueue the root node, which is 1, into the queue. Also, we take a count variable and initialize it to 1. As the queue is not empty, we enter the while loop. We pop the front element from the queue and TMP points to the front element. As temp is not null, the if condition is satisfied and we check if temp's left is not null. As 1's left is not null, we increment count and enqueue the left child of 1, which is 2. Next, we check if temp's right is not null. As 1's right is not null, we increment count and enqueue the right child of 1, which is 3. As the queue is not empty, we continue with the while loop, and now temp will point to 2 and 2 will be dequeued. Again, as temp is not null, the if condition is satisfied and we check if 2's left is not null. Since it is true, we increment count and enqueue the left child of 2, which is 4. Next, we check if 2 has a right child. As it is true, we increment count and enqueue the right child of 2, which is 5. Since the queue is not empty, we continue with the while loop, and now the temp will point to 3 and 3 will be dequeued. Since 3's left and right are both null, nothing is enqueued into the queue and value of count remains same. We continue with the while loop as the queue is not empty. So temp will point to 4 and 4 will be dequeued. Again, as 4 is a leaf node, nothing is enqueued and we continue with the while loop. So temp will point to 5 and 5 will be dequeued. Again, as 5 is a leaf node, count remains the same and nothing is enqueued. Now the queue becomes empty and we come out of the while loop and we return count, which is 5. So the size of this binary tree is 5. With this, we finish execution for this program. Now let us have a look at the time complexity of the program. This code will run in big O of n complexity. Here n are the number of nodes in the tree. With this, we come to an end of this tutorial. For any doubts or suggestions, please leave them in the comment section below. Thank you for watching.